All, let us see how to create a LED chaser project using STM32Cube IDE on STM32 F103C66 blue pill board. Okay, for that open STM32Cube IDE and then create a new STM32 board project. Sorry, and here you will have options to select the target. So type the target here C66A and you can select any of these and click on next below. It takes to you like LED slash chaser dash 1. Okay, next and then finish. You can leave the firmware package settings and all to the versions which are selected unless you have a specific name. So now once it's done, it opens up it creates a project basically on the left here and it opens up a .ioc file. Now on our board, we have PA3, 4, 5, 6, 7 where LEDs are connected. So here left click on a pin and set it to GPIO output. Okay, and then again left click, set it to GPIO output. Again left click, set it to GPIO output. Left click, set it to GPIO output. Every pin we are setting to GPIO output. Okay, once this is done, you know the clock configuration can be set as is, project parameter can be as is, tools can be as is. You need not worry about any of this. And if you want to see the GPIOs which are configured, you can check here. Now you can close this and save it, which asks you, do you want to generate the code? Exactly that. For that only we have selected these outputs, right? Click on yes. We want to be in the C++ perspective, right? So you can see here a code got generated, and then when you see the main function, you will see mxGPIO initialization, which actually, if you can see left click twice, and you can click on it to go to open declaration. Okay, you can see here these pins are written to a reset value. Okay, are written to a reset value. What is this? You can go here and you can see reset means 0, set means 1. This is enum, right? So the first one is 0, the below one is 1. So that means all the pins are written to 0 by default. So how to start with the LED chaser code? That's what we have to see now. Then see what we want, basically the LEDs to be continuously toggling, right? Like one after the another. That's what we want. So first LED should be on and then it should be off and the next LED should be on. That means there must be a chase that must happen between the LEDs. Basically LED chaser should be realized, right? So here if you see in the while, what we did is so first of all every pin is reset. Okay, and then we have added some delay. So we wrote a simple delay function, so you can write it as per your timing requirement. For now we wrote a simple delay function, and then what we are doing is we are actually writing a switch function with cases. So this is a code which is actually written for a serial port input. When you receive a serial port input, based on the input you have to blow an LED. So that we have modified such that we have written a switch input, and you can see there are several cases. For each case the break is missing and there is a break at the end case, which means when the execution enters into switch case, it executes continuously all these and then breaks when in the last case where there is a break. Okay, now what we have done is case 0. Okay, we have set LED which is 3 and we have reset all LEDs except 3. and then we have included some delay so that you can observe that LED is on. And then we have taken the second case where case one, sorry, where pin 4 is turned on, and all the other pins are reset. Similarly, we have continued in the sequence 3, 4, 5, 6, 7, and then there is a break. So this is how a simple code is written. So we will post this code in our blog. Okay, please have a look. And very simple code. You can use n number of ways. You can use simplified ways of writing this. If there is a bigger LED chaser to be done, it has to be done with functions. Okay. Now just have a look and let us know your questions. Let us look at the board and see how the LED chaser is functioning. Thank you.